By the end of this video, you would have learned how to write code and make the player move left and right. Not only that, I'll teach you some of the best practices of scripting that's going to make life easier for you as well as your teammates if you're working in a team, okay? So let's dive into some code. You know that I like to start a script by first arranging the brackets like so for better code organization, and I like to delete the comments so I can have some more visual space. Next, I like to start each of my scripts with a summary. You create a summary by typing in the / 3 times, 1, 2, 3, and there, summary. Remember the mnemonic, 1, 2, 3, summary. You may ask me why you need to use a summary. Let me show you. Summary can be used to write your goals during development. First goal is make the player move left to right. And then I like to write a sequence of steps to achieve this goal. These steps will be in plain English, and my task will be to read each and every line one by one and then translate it to C#. The next use of a summary is, let me show you. If I write player controller, you notice as you type, you have the IntelliSense telling you, make the player move left and right. So this is the summary. Imagine if you don't have any summary like so, and you save the script, and then you try to use the player controller class. Well, you have no information about it. Imagine if you're working in a team and your colleague gives you a class with no information, no summary. Imagine how you would feel about it, right? So it's a standard best practice that I use, and I encourage you to use it. So let's have a look. The first line tells you to create two methods, move horizontal and stop moving. So let's copy these two methods, paste them here, copy move horizontal, paste it here, copy stop moving, and paste it here. You've just completed the first step. Next, line number 2 says get the input using getAccessRaw and call these methods in update. Which methods? Move horizontal and stop moving. Let me show you. Let's head over to Unity, and first you need to understand that this player will move when you press the left arrow key and the right arrow key. The player will move left if the velocity of the player in the x-axis will be negative. The player will move right if the velocity in the x-axis will be positive. Okay, remember this. The player will not move if the velocity in the x-axis will be 0. Okay, using this knowledge, let's get back to our script. We can capture the velocity of the player in the x-axis. And how? Let's have a look. We will store the x velocity in a float variable called player speed using the input.getAccessRaw. And I'll tell you in just a moment why we use raw. And the reason we specify horizontal means the x-axis. Let's write a comment. Value will be 1, -1, or 0. Input.getAccessRaw will always check if the left arrow or right arrow key has been pressed. The left arrow will return -1. The right arrow will return +1. And if none of these two arrows have been pressed, 0 is returned and stored in player speed. Since this piece of code is in update method, and update is called every frame of the game. Okay, and what do you mean by the frame? Let me show you. Let's go to the play mode, and you notice these 3 buttons. This is an update. If I press this, this will refresh the screen every time I click. One click and one refresh happens. Another click, another refresh of the screen happens. And with every refresh, Unity figures if there's any change that has happened to any of these game objects in the scene, and Unity reflects the change. A video game is nothing but a continuous reflection of these changes. So updates happen really quickly. So you can manually do an update like this, and in the play mode, updates are happening really fast. And that's why you see this cat in the idle motion, because with every frame update, let me show you here, when I press, you notice the cat is actually moving with every click. Okay, so with every screen refresh and update, the changes are reflected. With this knowledge, let's get back to the script, and with every update, the player speed will have one of these 3 values. Next, let's use an if block and check for the player speed. Remember, this player speed is nothing but the velocity x of the player, and I'll just get to it in step 3. So we need to check if player speed is not equal to 0, okay, means the value will be 1 or -1. Players moving in the left or right. So we have to perform the movement. Move horizontal will take care of the player movement, else stop moving, which will take care of stopping the player. Right now these methods are empty, and we're going to fill these in step 4. In step 3, to move the player, we need a rigid body 2D reference. One of the important things in C# scripting in Unity is to be able to access these components. This player controller script can have code which can access the rigid body 2D, box collider 2D, sprite renderer, animator, transform, make some changes to them, and that's the core of video game programming in Unity. Okay, we write scripts. These scripts can access these components, make changes, and have some interesting gameplay happen. Back to the script. So we're going to access rigid body 2D. So we need a variable of type rigid body 2D to store that reference. We're going to write RB equals to get component of type rigid body 2D, and this piece of code will get the component of type rigid body 2D, which is attached with the cat game object. Once you have the reference to the rigid body 2D, let's move on to step 4, write code to move and stop the player. So let's start with moving the player. Now you know that the rigid body 2D has a velocity property, and have a look. The use of summary is so important. If there were no summaries, the IntelliSense will not tell you what the velocity is or anything, right? So this tells you that velocity is a linear velocity of the rigid body. So let's assign a new velocity to y vector 2, because this is a 2D game. Okay, we're going to assign the directions only in the x and y axis. This takes in 2 parameters, x and y. So let me tell you, move horizontal needs to know the player speed, which is here. But in this method, we're not passing any parameter. So let's do that. Let's modify this method to take in a float player speed. Now you can copy this and paste in here like so. And for the y, you can say rb.velocity.y. Let me explain. Every time you call the move horizontal, you're going to pass in player speed. When Unity reaches this block of code, it's going to check that you're trying to assign a velocity to the rigid body 2D velocity. And this velocity will be a new vector 2, which is taking in the x and y component. In this case, x is clear. It's this player speed that you got using the input.getAccessRaw. Why are you assigning rb.velocity.y? Because we're only interested in our goal, to move the player left and right, not top and bottom. So let the existing velocity in the y direction be as it is. Okay, we're not going to mess around with this velocity. We're only changing this. So this piece of code will move the player left and right. It's time to test. Head back to Unity. When I hit the left arrow key, notice the player has started moving in the left direction. And holding down the right arrow key, the player starts to move in the right direction. Okay, let me ask you a question. Why is the player moving so slowly? Okay, the answer is, currently the speed of the player can only be 1 or -1, okay, because of this. So if you wanted to improve the speed, we could do a speed boost. So let's assign a public integer variable called speed boost, okay, and what we're doing is the last step. Step number 6, increase player speed. This speed boost will be multiplied by the player speed in this manner. Player speed, and using this assignment, we are essentially telling to multiply the existing value of player speed with speed boost. Okay, let me write a comment. This is equal to player speed equals to player speed into speed boost. So this is same as this. Once this happens, the speed of the player will increase. But remember, this is a public variable. So set this to 5. And 5 is a predetermined value, which I got through trial and error. So let's have a look. Highlight the cat. And this time, in the inspector, you'll notice you have a speed boost public variable. Change this to 5. Hit Command S, time to test. Go to play mode. And now, when I hit the left arrow key, whoa, the player is moving faster. But notice the moment I release the left or right arrow key, the player is sliding as if there's ice below, but I don't see any ice, right? So what's going on? Here, stop moving does not have any code. So it's very simple. rb.velocity will be changed to a new vector 2, and this time the x velocity will be 0. The y velocity will be as it is. We're not going to mess around with this. That's it. This completes step number 6. You can test now. There, the player stops moving the moment you release the left or right arrow key, and the left and right movement is taking place. So there you have it, the left and right movement for you. But before we move on to the next script, let me show you another important and useful best practice that I use. Let's exit the play mode and have a look in the inspector. You have this public variable called speed boost, and you know that this is an integer, and it's you who knows that it takes a positive integer, and it helps in improving the speed of the player movement. But imagine if you're working in a team which has a designer, which has a quality analyst, other developers, and probably a team leader, and you also have a manager, okay? These scenarios are very common. And if they look at the inspector and they look at speed boost and they have no documentation around, you're not there. It's hard for them to understand what this is. I agree we're using these descriptive names, but then how can you specify ranges? How can you specify some description? Well, there is a way. Have a look. Unity does it, and it's recommended. Rigid Body 2D or any other component has these properties, and if you hover the mouse over a property, boom, you've got a tooltip. This is cool, right? Angular drag, linear drag. So let's go ahead and implement our own tooltip. You open and close square brackets, type in tool, and you get the IntelliSense telling you we can specify a tooltip. Perfect. Hit return, open the bracket, and you can specify the text for the tooltip. You might want to close the bracket also. This is an integer, or this is a positive integer, which speeds up the player movement. Bingo. Save the script, head over to Unity, and now you'll see after the compile is completed, watch what happens. Hover the mouse over speed boost, and boom, this is a positive integer. So great job. So now you have it. These are some of the basics and the standard best practices which I recommend. Now this player is moving left and right. In the next video, we will write code to make the player jump. So I'll look forward to joining you in the next video.